Today is the first exclusive webinar for Oasys Slope. I'm going to be your presenter for today, so my name is Zina Farouk. I am a geotechnical engineer by practice, and the webinar objectives for today are that you should be able to apply the analysis theory to produce designs, and also that you can present the analysis results for use in reports. So hopefully this would be a useful webinar for you practicality-wise. So the structure of the webinar today is that we're going to cover a little bit of theory, just briefly. I'm going to go through one or two case studies so that you know how the software works before we go into a live demonstration where I demonstrate setting up a problem, adding reinforcement, running a ULS analysis, and various other things. And also I've got a little nugget for you today where we're going to introduce to you the new Oasys Slope. The developers have been working hard to release a new version of Slope, which does a lot of different things and has quite a different interface. So I'm sure you'll be excited to see that. So to start off with, what is Slope? Slope is designed to analyze stability of slopes with the option to include reinforcement. It can also be used to analyze earth pressures and bearing capacity problems. Now, Slope is often used for soil and rock slopes, and the reason that this can be done is because it considers circular and non-circular slopes. And Slope has a lot of extra features. So, for example, you could add reinforcing elements such as rock bolts, soil nails, ground anchors, and geotextiles. There's an option for factoring. There are a number of options available, and it's all based on methods of slices and limit equilibrium analysis. So if I go into the analysis in more detail, there are three main types of analysis: the Fellenius and the Bishop's method for circular slips, and the Janbu method generally for non-circular slips. And depending on what kind of factoring you're using, what kind of slip circle you're interested in, for example, you would choose the method accordingly. There is much more information about these specific methods in the user manual, so I suggest you have a look at this if you are interested. It is important to understand the slope inputs because that gives you an idea of how the program works, and we're going to really familiarize you with this in the run-through. But very briefly, you need to give information about ground sections by layer of materials. So what you do is you type in the strata, you type in the material properties, such as the variation of cohesion or the strength of materials. You give information about the groundwater profile, reinforcement. You can put external forces. It can be horizontal or vertical or tangential. And you need to put information about the slip surface in. So, for example, are you looking at a slip surface that already exists? So basically, you might be looking at a single slip circle. Maybe you just want to find the worst case slip, in which case you're looking at a grid. And there are different ways of specifying circles, going through a common point, just as a radius going out, or tangential to the surface. So depending on the type of analysis and the design you're doing, you have to specify that accordingly. It is worth mentioning here also that Slope has a number of features. So for example, you could even look into earthquake analysis and how slopes behave under earthquakes and various other things as well. So those options are available to the user. In terms of the output, there are two types of output. One is a very detailed tabular output, and this gives a lot of information about the slip circle. So this would be quite useful for any kind of design that you're doing. But we also have a graphical output. Now, the graphical output is really good for reports or presentations. It's very useful for helping the client understand where the failure is going to occur and how it occurs. So it just depends on your needs as to what you use, and especially with the graphical output, we'll really familiarize you with this in this particular webinar. So on to the case studies. With the case studies, we're going to present two case studies to you today. One which will show you how the program works on a large-scale project, but the other one will show you how the program is used in a different type of analysis. So hopefully both of them will be useful to you. Okay, so for the first case study, I'm going to briefly touch on the Nouvelle Autoroute 30 Montreal, which was a massive highway built in Canada. It was completed in 2012. Now, Slope was used extensively on this. It was used to design the embankment material, and it was used for the earthquake formation. So for this particular analysis, Slope was divided into zones with various shear strength characteristics. A number of failure surfaces were checked, And there was a higher factor of safety chosen for this project, which is 1.4, and that was due to the brittle nature of the champion clay. So this is just an example of the slope stability analysis that the Arup designers produced. As you can see, we've got some loading from the traffic at the top. We've got the embankment and formation from with various properties. As you can see, the grid has been chosen here, so they're looking for the worst case slope stability surface, and you can see this slip surface here is the worst case. As you can see, we've got marine clay and we've got groundwater as well shown. So it just gives you an idea of the kind of properties of slope and how it's used on a bigger project. But we are often asked about how it can be used with something a little bit different. Say, for example, if you're carrying out a basement impact assessment, if you're looking at retaining walls, how do you use slope? Well, Arup carried out an analysis on a proposed redevelopment, which was the enlargement of an existing lower ground floor and the construction of a rear basement. Arup required to assess the potential impact of the proposed development on the local surface water and groundwater environment, but more interesting for us, on the stability of the slopes in the immediate vicinity. So for the enlargement of an existing lower ground floor and the construction of a rear basement, why would you use a slope stability analysis? Well, by building the basement, the natural ground is altered, and the site within the area of previously worked ground, the site is within an area of previously worked ground, and it's also within 100 meters of potential spring line, which is underlain by a minor aquifer. So they had to look at the effect of the groundwater. The proposed basement will probably be extended below the water table, and it was also a local authority requirement. So with all this, the Arup engineers ran a long-term stability analysis of the clay, which was supported by underpins. Oasys slope analysis confirmed that the underpins alone would not satisfy the overall stability requirements. So for this particular analysis, what was done is that the engineers carried out a Eurocode 7 factored analysis, and they stated that the concrete ground-bearing slab could be incorporated as a prop at the base of the underpins. So if I go into this analysis, so as you can see, with the general parameters here are chosen as circular with a static analysis. And as you can see, we've got, if I go into the graphical input, you can see we've got a retaining wall here with the strata around it. So if I look at the wall itself, if I go to the material properties, you can see that the concrete has been given properties with full cohesion and no value of phi, so it's a completely drained analysis. And for the surface loads, we have a horizontal load representing the prop. And finally, it's worth mentioning that for this analysis, the engineers have carried out a Eurocode 7 design approach 1 analysis. So if I just carry out the analysis for this, as you can see, we're getting a factor of safety of 1 with the prop in place. So if I just choose the worst case slip surface, as you can see, we're getting a factor of safety of 1 around there. So that's acceptable, and that's because the prop has been input in. So that's, in a way, it gives you an idea of the way the program is used and where various things are. It just goes for me to say that you can actually have a look at the slope tutorials. We're writing up one over the next month or so. So you should have a step-by-step tutorial available. And that could be accessed via the tutorial section of the product page. So on the product page, you can click on any of these video tutorials, and hopefully we should have a PDF tutorial available to you as well. Related webinars are available, so you can have a look at what webinars were there previously. And if you just want all of this in one place, at the bottom of the Oasys page is a link to YouTube. Type in slope on our YouTube page and you'll get up everything. We do also like people to contact us, so please feel free to email us or call us. We're happy to take any queries about the program, any queries about its use. There are also technical FAQs that you can look at. So thank you very much for your time, everyone, and I hope this was useful. Are there any questions?